Hello and welcome to another edition of Ty Does Maths. This is the OCR 2019 Pure Maths and Mechanics paper for AS level. I'm just going to work through the papers and show you how I'm getting the answers. There might be different ways of doing the questions. These are just the ways I'm thinking as I'm going through doing the questions. Okay, so if you know a better way, congratulations. Right, so let's have a look at question early on. I'll probably do two questions and stop the video and start it. So if you want to look at particular questions, you can just find the one that you want to find. Says the opening question, solve the equation x into 3 minus root 5 equals 24, given answers in a form a plus b root 5, where a and b are both positive integers. Okay, so let's just write the question out to start with, number 1. So we're going with x bracket 3 minus root 5 bracket equals 24. Okay, now there's no point jumping on a calculator to do this on because you wouldn't give it the exact form, so you need to do it properly now. So it's times on this side divided on the other side, so x is equal to 24 over 3 minus root 5, and then to rationalise the denominator we just need to multiply by 3 plus root 5 over 3 plus root 5. Okay, and so that rationalises it. This is going to give you on the top 3 for 24 is 72 plus 24 root 5. Okay, and then on the bottom this is a difference of two squares, so you're just going to get 3 times 3 is 9, take away, and then root 5 times root 5 is just 5, and then when you expand double brackets the other bits are going to cancel out because it's the difference of two squares. This thing equals 72 plus 24 root 5 over 4, and then you can divide both these numbers by 4. So 4 into that one is 18 plus 4 sixes are 24 root 5, and that's a 2-point question. Okay, 3-point question even, so 3 points for that question, pretty straightforward. Next one we've got number 2. So it says this one over here says express so 5x squared minus 20x plus 3 in the form p into x plus q squared plus r, where p, q and r are all integers. So it's basically asking me to complete the square on this thing. So the first thing we do is we get the x squared by itself by factorising out the 5. So we've got x squared take away 4x, and we're not bothered about the plus 3, so we'll just leave the plus 3 floating about at the end. Okay, now completing the square on this thing is equal to 5, and then a bracket. Completing the square here is going to be x take away 2, you just half this number, and then you always take away, squared, you always take away whatever this number is squared, so take away 2 times 2 is 4, and that's in the brackets, that's completed the square part, and then you've got the plus 3 at the end. Expand out the brackets, so you've got 5 into x minus 2 squared take away 20, so that's 5 times that one, 5 times this one, and then you've got the plus 3 floating about at the end. And then finally you can tidy up this last bit to get 5 into x minus 2 squared take away 17, and that's the answer to part A. Okay, so our P is 5, the Q is minus 2, and R is minus 17. Part B, it says now state the coordinates of the minimum points, and the thing about the minimum points of part B is that the smallest this can possibly be here is 0, because you're squaring it, so you can't make this negative. Anything squared is positive, so you can only go down to 0, and this equals 0 and x equals 2, so we've got 2 is x, and if this is x then y is going to be minus 17, so we've got 2 minus 17 as our minimum point of the curve. Y equals this lot. State the equation of the normal to the curve. Well, if you think about the actual curve, so the curve goes like this thing. Okay, the tangent would be at the bottom, so at the minimum point. State the equation of the normal, so the tangent would be there, wouldn't it? And we know on our graph this is 2 cross minus 17 down, so let's just put some numbers on here. So there's 2, and this will be minus 17. Now this is the tangent here. Now I want the equation of the normal. The question says, so normal is the one that's at right angle there, so it's this line here, and the equation of this one, so part C, is x equals 2. Okay, and that's question 2 done. Alright, shall we do question 3, because we seem to have plenty of time. Let's try to do question 3. I'm only at 5 minutes. So question 3 on the back. So question 3 says sketch the curve of y equals minus 1 over x squared. Okay, So we just think of what's going on here. Okay, so there's my axes, x and y, x and y. Right, so for a start, x can't be 0, so we can't be crossing over this line, so we're definitely not crossing over the line there. Y also can't be 0, because if you rearrange this thing, you'd bring the x squared to the top, you bring the y to the 0, so we can't cross over the x-axis either. Okay, so we can't cross over the two lines. So what else is happening? When x, so this is always going to be negative, so this is always positive, x squared is always positive, this is always going to be negative, so y is always going to be negative, so we're in the bottom half of the graph and we're not crossing over the line. X can be anything, so we can be both sides of this graph, so there's going to be two parts to the actual graph itself. When x is really, really small, this will turn out to be really, really big but negative, so it'll be really, really small, so all the way down here somewhere. When x is small, it's going to be down here. When x is big, this thing is going to be really big, and that's 1 over something really big is something really, really small. Negative, it's going to be over here somewhere. So what's happening on this side is the graph's going to curve up into that point, and then just get closer and closer to the axis, but never actually cross the axis. And then the same thing is going to happen when x is negative now. So when x is negative, when you square it, it becomes positive. So the same, but then the whole thing turns out to be negative at the end. So when x is negative, it's going to be the same graph on the other side, and it's just going to look something like that. Okay, and these are just approaching the axes. That's at one point. Right. The curve y equals minus a half. 1 over x squared is translated 2 units in the positive x direction. Okay. Now what I like to do here is I always like to have it as function notation. So instead of saying y equals, I'm going to say f of x equals minus 1 over x squared. And that just helps my thinking, because I know about transformations of graphs. Now what the question is asking me to do, it's asking me to move the translator, so we're going to move the graph 2 units in positive x direction, so we're going to move it that way, 2. So that would be f of x minus 2, okay? So when we teach this bit, I always say weird things happen in the brackets. Minus, you'd expect it to go that way, but in fact it goes that way. What does this look like? It looks like minus 1, and you just replace x with x minus 2. So x minus 2 squared, so that would be the equation. And then going back to the y, I've got y equals minus 1 over x minus 2 squared, and that's how I figure out these ones. I just change it into function notation because I know what's happening on function notation. So that's part B. And part C, we have the curve is stretched parallel to the y-axis. Let's just write the fx thing. So f of x equals minus 1 over x squared again. Okay, is stretched parallel to the y-axis, so parallel to the y-axis, okay, and by a factor of a half. So what does that mean? So we've got, there's the y-axis there, and we're going to stretch it parallel to the y-axis, so we're probably going to go straight up and down. So we're going up and down by a factor of a half. Okay, so half times it by half there. Okay, so if you're looking at in function notation wise, you've got half of f of x, okay, and that's going to be equal to minus 1 over 2x squared. Okay, so there's the half bit hiding in this minus 1 over 2x squared thing. So that's what the graph looks like, the equation looks like. As a result, the point a half, as a result, the point half minus 4 on the curve is transformed to the point P. Now I don't actually need this thing because I can just look at what's actually happening on the graph. So if I look at the point P on the graph, so we're on half across, so we're at a half there, and we're at 4 here, minus 4 down here. And what we're doing with this stretch is we're bringing it in by a half the distance, so it's half in the distance up, so it's actually going to end up here when we stretch it in, so it's moved from there, half the distance up to there, and that's obviously going to be at minus 2. So the coordinates of the point are going to be minus a half, comma, minus 2. Sorry, not minus half, it's just normal half, isn't it? So it's at a half, so it's half 2. So plus a half, and then minus 2 is where it's at there. I don't know why I put minus half there, just stupid. Okay, that was a 5-mark question. It was 1 for the graph, it was 2 for the equation, and then it was 2 for this point. You get 1 point for each of the coordinates. I'm going to stop there on 10 minutes, okay, and we'll come back and do other questions in a second.